So effectively, we said the microcontrollers that we're going to be using will be implementing the C++ code or Arduino code. So as a refresher for the Arduino code, I would like to look at the following 5 different issues. We'll look at the variables, we'll look at the operators, flow control, functions, and any other issues that you might come across while coding for the embedded system. Now, the first issue of variables is variables. Remember, inside the core, there is an arithmetic logic unit which works by manipulating register values. So those register values are in fact variables in the code. So variables are addresses to the memory location, and in C++, the variable must have a type, and it must be declared before being used. So the declaration of a variable, in this case, it will state the data type as well as the variable name. Now, for example, there are multiple types of variables. We have a Boolean variable, which is an 8-bit of size 8 bits, and it's a simple logical variable which can either state true or false. Another type of variable is called a byte, which is an unsigned number between 0 and 255. It's also 8-bit. And then we have an integer, which is a signed number between -32,768 to the positive value of that, and it's 16 bits long. Apart from that, we have a bigger variable, which is a long, which is 32-bit signed number with a bigger range. And then we also have a float, which is a much bigger number. It's also 32 bits, but it can represent much bigger numbers. So in this case, it's always important to identify what the data that the microcontroller is going to be manipulating, what would be the appropriate variable for that. Variables can also be placed in the form of arrays. For example, here we can say float, temperatures. Float is a type, data type. Temperatures is a variable, but the square bracket 6 means it will simply have 6 elements within it from 0 to 5. So the temperatures can be initialized in such a way that it has these 6 values: 11.1, 12.2 up to 16.1. This is just an example. Now, besides the variables, we have operators of the variables. So variable values can be manipulated using operators, and the operators can be either arithmetic operators, relational operators, or logical operators. And so the arithmetic operators would be simply the addition, subtraction, multiplication, division, as well as the modulo operator. And they work the same way as basic arithmetic that we know. And then you can have, besides that, relational or comparison operators, whose result has to be true or false. And typically, for example, if you say this is an equal to operator, so the result of this 0 is equal to 1 will simply be false, because 0 is not equal to 1. 0 is not equal to 1 will simply be true. Here are the other types of operator. Comparison operators, such as the less than, greater than, less than or equal, greater than or equal to. Another type of variable would be the logical operator. In this case, it's when one wants to merge two statements, which can either be false or true. We have the AND operator, we have the OR operator, we have the NOT operator. So in this case, an example, we can say A and B is false. Here we simply mean when A is false and when B is false, this whole result will be true. So we have here A or B. This will simply be a comparison between the two variables, the two statements embodied in A and the other statement embodied in B. We can have as well a NOT operator, which is a logical NOT, which simply inverts from a truth to a false. So in terms of flow control statements, the most important statements that we will see from time to time are the if or if else statement as well as the switch statement. For the if statement, what it simply does, it's a block of code. It's executed if and only if the condition in the bracket is met. So in this case, this block of code will be executed if and only if this condition is met. And the if statement can also be combined to create an if else statement to give a secondary condition, as in this case. And then also you can also have an else statement going with it to give a default statement that's executed if all of these above statements are not if all of the above conditions are not met. In the case of the switch statement is like a statement which which executes a certain block of code based on the value of a certain variable. So in this case, this variable, based on the value of this variable, if this variable value corresponds to label 1, then it will execute this block. If it corresponds to label 2, then it will execute that particular block. So these are some of the ways in which the algorithm can control the flow of the flow. I mean, so in which these are some of the ways in which the flow of code can be controlled using the if and switch statement. The other type of flow control in this case would be the loops. So the loop simply means you put in a statement which executes a certain block of code for a given number of times. So in this case, you, like a typical C++ function as language, you would have a do while statement, you have a for statement, you also have a while statement. So this is an example here of a do while statement where the sensor is read while this condition is met. You can also have a while statement such as this, where this would be the condition of the while statement and this would be the block of code that we executed a number of times. In this case, this would execute 200 times. And then alternatively, we would have the for statement, which initializes the counter, and this counter will be iterated by increasing it by 1 each time up until it reaches 255. So this would be very similar to exactly the same way as you would in C++, part, you know. And then another way of organizing the code would be in terms of functions. So when you have blocks of code which you would like to repeatedly execute, one way or one elegant method of doing that is to have a function. So a function such as this void blink LED. So a function will have a function name. In this case, this would be a blink LED. It will also have input parameters. In this case here, it does not have input parameters. Input parameters would have to be in between these brackets. And sometimes it has a return type. But in this case, this is not a good example of that because the return type is void. It doesn't have it. If you look at the second function here, the second function, in this case, this function would have the function name. This would be the function name. And then this would be the input parameter, Fahrenheit. And then the float would be the return type. In this case, the return type. So it returns the value which is float. So this function must be defined separately outside the two normal functions that you'll find in a Arduino block of code, the setup and the loop function. And they can be called within each one of these functions to execute. The other commonly seen issue in Arduino code is whereby you will notice that obviously, like C++, each statement is terminated by a semicolon. This is so except for these two statements, define and include. So include would be used to include an external library. Define would be used to define one of the constants that we'll be using. So in this case here, you will see an example of include ESP8266 Wi-Fi. So this would be the library, the Wi-Fi library for ESP8266. And then here you would define what this pin, you define a new name for this pin. So for this pin D1, you define a new name which is an input, or for this pin number 16, you define a new name left out. So define allows the programmer to give an appropriate name for a constant for your applications, which makes the code easier to read, and it can be used to label the input output pins or any other fixed values in the code. So it simply makes the code easier to read, because now every time instead of writing 16 you write lamp out. Therefore every time you want to refer to pin 16, you just refer to it as lamp out. The include is used, it's placed on top before the setup function, and it allows the inclusion of multiple libraries to extend the functionality of your sensor node, sensor actuator node, or embedded system. And so it can include user-defined functions, giving the hardware new capabilities or making it easier to implement certain functionalities. So in fact, this is basically what the include function can be used for. Another important thing which I also wanted to mention was the fact that, for example, there are those functions or variables which are inherent in Arduino, which have an inherent meaning in Arduino. For instance, the UART output here, by default, it will be called serial. So in the setup, you attach serial.begin. This is the setup where you are setting up the communication between the UART communication between the microprocessor as well as the computer. And in the loop, of obviously you would put in whatever you wanted to print on the serial. So this communication baud rate must match the one that the serial the computer will have on that particular port for them to communicate together. This I think you will see in later examples if it's not clear for now. So there is a comprehensive language reference for Arduino and a lot of libraries. You go to the Arduino CC website or do a Google search of some of the freely available libraries. Now, on the issue of the algorithms, remember the code we are using to implement a certain algorithm. So one such case is where you design the control logic for the embedded system. So an algorithm would be implementing the control logic, and there are two ways in which you can specify this algorithm. One way would be to use a pseudocode. The other way would be to use a flowchart. The pseudocode in this case would be simple English expressions describing the operations that must be done step by step, and it's something that has to be programming language independent. So it has to specify the sequencing, how the steps are sequenced together, selection if it has to select, if the algorithm has to select between two or a certain number of options, and iterations as well. So it has to show if there is something statement that needs to be looped, if there's a loop in the execution. So this can be done in that way. A much more clearer way I contest would be to use flowcharts. Flowcharts are graphical representations of the algorithm, and in my opinion, these are better to read than pseudocode. And they have three types of they have many types actually, but I think I would want to highlight the three types of steps that can be put in the algorithm. You can have an oval shape which indicates the beginning or the end of the algorithm. You can have then a diamond shape which shows the condition of the algorithm. So this would be something that indicates the condition. The interesting thing about this is that only when you have a condition are you going to have a case where you have two outgoing arrows out of one block. So in this case, you only have one outgoing block. In this case, only one. In this case, only one outgoing block. Or only one outgoing arrow. But in the case of a condition, you can have two ways in which the two arrows going out of the block. In this case, you have a condition number one, which will be corresponding yes, and then condition number two, which will be corresponding to a no. So this would be the case. This is what the condition would be, the conditional block, which is a diamond, would be used for. Then you would have a typical case of a rectangle, which will simply specify the statements that need to be executed, or the steps that need to be executed at that particular point in time. As an exercise, you can make an example of how to cook a meal. You can create actually a pseudocode explaining how to cook a basic meal, maybe a bowl of rice, a roll of pap, and then you can write that as a pseudocode, or you can even write it down as a flowchart. So later on, we will have to see then how this flowchart that would have constructed the algorithm using can then be translated back into the Arduino code. So for instance, here, if say for example there was a flowchart like this, where you had a step at one point of the algorithm, you have to assess some condition one. If the condition is true, then you do statement one. If the condition is false, you do statement two. This can be easily put in the form of this if else block. This translates to this if else block. If condition one, so the if and the condition will be in this case. If that is true, then you will execute statement one. Else, you will execute statement two. So in fact, the whole of this algorithm that would have been developed would then need to be translated into a couple of statements in order to execute it. So this will be done later in more depth with exercises. Let us consider then for a moment implementing one of the first algorithms in ESP8266. Say for instance we wanted to blink an LED light, an onboard LED light, for each and every half a second. And we can quickly then realize that from the language references that we have a function called delay. So this inbuilt function is used to pause the execution of the microcontroller for a certain number of times, and 1 second, the argument for this function delay is given in terms of milliseconds. So if, say for example, we wanted to have 1 second, this would translate to 100 milliseconds. So then we could use this simply to implement the blink function. So here now are two examples of how this can be done. The first one here is inside the setup. We first of all configure the mode of the pin which attaches to the inbuilt LED. You realize that there is a variable here which has not been declared, which is called LED underscore built in. This variable is known throughout the Arduino environment depending on the hardware platform that has been selected. So this LED, this particular pin would be used in this case to designate the LED pin on this particular board, and then that particular pin which is connected, that we designate it as an output, so that we can then control it in the setup. We designate it as an output in the setup, and inside the loop then what we do is we momentarily turn the pin to high, and then we delay that for half a second, which is 500 milliseconds, and then we momentarily turn the output low. And this turning of the output low will change the status of the LED and wait for 500 milliseconds, and so on and so forth. So this then, because it's a loop, it will execute the next statement after 500 milliseconds, and to go and on like that for forever and ever. So in this case, this will give an effect of turning on and then turning off the LED each and every time 500 milliseconds apart. Another way of doing this would be, first of all, to declare a variable for that particular pin. So in this case, for our board, the LED for the ESP8266 is connected to pin number 2. So the GPIO number 2 would be the one which connects that. So we declare then a variable that the pin is equal to 2. This we do because it makes it easy for us to remember now what we are referring to every time we refer to that particular pin, instead of just using the number 2. So so similarly, in this case, we can just then designate that pin to be an output, and then give it a high signal, wait for 500 milliseconds, give it a low signal, wait for another 500 milliseconds, and so on and so forth. So both of these pieces of code would be able to implement the blinking of an LED, onboard LED on the ESP8266. Now, one may think, of course, that okay, now that you have blinked an LED every 2 milliseconds, every half a second, is it possible then to say, let's say you blink an LED every half a second and twice every second, you know? So sometimes you may want to do such an operation. So sometimes this delay function that we use cannot be used in some of this implementation, because the delay function, once you use it, it simply blocks the execution of the whole microcontroller, installs it. So such an example here, if you attempt it, you may find out that you cannot do this with the delay function. Thank you very much for your attention in this lecture 1. Let's meet again in lecture 2.